Hi class. For this lecture video, we will be learning about the Lorentz velocity transformation. So the velocity in S prime in terms of the velocity in S is given by this equation. So we have V sub x prime is equal to V sub x minus u divided by 1 minus u times V sub x over c squared. And for the Lorentz velocity transformation in S in terms of the velocity in S prime, we have this one. We just have to change the primed to the unprimed. So we have V sub x is equal to V sub x prime, and then we have a we have to change the sign of u. So we have plus u over 1. We have plus u v sub x prime over c squared. Okay, so let us try to derive this transformation. Suppose that in the time dt, so this is an infinitesimal amount of time, a particle moves a distance d sub x as measured in frame s. We obtain the corresponding distance d sub x prime and time d sub t prime in s prime by taking the differentials of the Lorentz coordinate transformation for x prime and t prime. That is, if you can recall, in the previous video, we have obtained x prime is equal to gamma multiplied by x minus u t. So, taking the differentials of x prime, we have dx prime is equal to gamma, which is just a constant, multiplied by dx minus u multiplied by dt. And the differential for t prime is this equation. We have dt prime is equal to gamma multiplied by dt minus u dx over c squared. Okay, and then we divide the first equation, we divide this equation by this equation. So we have dx prime divided by dt prime is equal to dx. So notice we can cancel gamma out since it is present in both the numerator and the denominator. So we have dx minus u dt divided by dt minus u dx over c squared. And after this, after dividing dx prime by dt prime, we divide the numerator by dt and the denominator by dt. So in doing that, we will obtain this one. So we have dx prime over dt prime is equal to, again, we divide the numerator by dt. So we have dx over dt minus u times dt over dt divided by the denominator, which was divided also by dt. So we have dt divided by dt minus uc squared multiplied by dx over dt. Okay, so this one, dt over dt is just 1. And this is also equal to 1. So we have dx over dt minus u divided by 1 minus uc squared multiplied by dx over dt. Now, dx prime over dt prime is just equal to v sub x prime. So this is the velocity as observed by an observer in S prime. And dx over dt is just equal to v sub x. The change in x with respect to time is just equal to v sub x, which is the velocity as measured by the observers in S. Okay, so substituting this into our equation, so we will get this one. V sub x prime is equal to v sub x minus u divided by 1 minus u over c squared multiplied by v sub x, which is exactly the same as the equation that we had in the previous slide. Okay, now notice that when u and v sub x are so small compared to c, so take note that c here is the speed of light in vacuum, which is equal to 3 times 10 to the 8 meters per second. So if u and v sub x is much lesser than c, then this equation will just approach into v sub x minus u, which is very familiar because this is exactly the Galilean transformation for velocity. Okay, so uh, when u and v sub x is small compared to c, much smaller compared to c, then the expression in the denominator will approach to 1. So this one here, a small number divided by a large number. C squared is a very large number. So this is negligible. It is closer to 0. So this expression in the denominator will approach 1. Therefore, we have v sub x prime is approximately equal to v sub x minus u, which is just the Galilean transformation for the velocity. And also, when v sub x is equal to c, so let us try to substitute c into our v sub x term. Then we have v sub x prime equals c minus u divided by 1 minus u times c divided by c squared. We can cancel this c here. So in the denominator, we have 1 minus u over c. And manipulating, taking out c, factoring out c, in the numerator, we have c multiplied by 1 minus u over c divided by 1 minus u over c. So canceling out this term here, we will get c. So when v sub x is equal to c, or shall I say when an observer in the S reference frame, inertial frame of reference S, measures the speed of light to be c, then the observers in S prime will also measure the speed of light in vacuum to be equal to c. So this is consistent with Einstein's second postulate that the speed of light in vacuum is the same in all inertial frames of reference. Now, if we use our technique in getting v sub x in terms of v sub x prime, then we just have to change the primed or the unprimed coordinate into the primed coordinate. We just have to change the unprimed term by the prime term and we have to change the direction of u, or the sign of u. Therefore, our v sub x is equal to v sub x prime plus u divided by 1 plus u times v sub x prime over c squared.